Hey, pre-algebra class. Welcome to another episode of Mr. Chow Time. Today, we're working on simplifying algebraic expressions, lesson 2, page 299, if you're following along the book. All right, so let's take a look at what this means to simplify an algebraic expression. Well, remember, an algebraic expression is an expression, which is what's on one side of the equal sign, but it has an unknown in it. It has a variable, right? And that's what makes it algebraic. So if we had something like 2x plus 3 minus 4x plus 7, I don't know. This would be an algebraic expression. And so in order to simplify that, first let's talk about some of the vocabulary that goes along. Each one of these little pieces is called a term. So each of these is a term. The coefficient is so these are terms. How should I do this? These are terms, okay? Coefficients are the number that is multiplied by the variable. So in this case, this variable x is being multiplied by 2. This variable x is being multiplied by -4. A constant is a number. And it's called a constant because it's constantly that. So for example, this 3, it's just a 3. It's never going to be anything other than a 3. This term cannot change. This term cannot change either. But this term, 2x, can change depending on what x is. So it's variable. This is a constant. Okay? Okay. Like terms are pieces that can be combined. So the 7 and the 3 can be combined to form a new constant, which would be 10, right? And the 2x and the -4x can also be combined to make a new constant, which is -2x. And so these pieces are like terms. Okay? Okay. So as I talk about these things, if you forget what I'm talking about, you can come back to this slide to see what those terms mean. So we're going to identify the like terms in the following expression. So I'm going to color coordinate this to make it a little bit easier. So 3x and 4x are like terms, and those are the only like terms. 5x and 7y are like terms, and 3 and 4 are like terms. Okay, your turn. I want you to identify the like terms. Okay, welcome back. So here, 2y and 3y are like terms, and -4x and 2x are like terms. All right. Don't forget that when you're subtracting a value, that means that the value is negative. So when I've been writing this up to now, like this plus, it's not really a plus x. It's just a positive x, right? A plus just means an operation. But a subtraction is an operation and a signifier that it's negative. It can be both things. In fact, it is both things. So one way that you can think about this is, well, basically that anytime that you see a negative, that negative is attached to, or the subtraction, that means that it's a negative attached to that term. So if we were to look at this and identify the terms would be 6x. Oh, I don't want to include that negative in there. 6x, negative 2y, x, and negative 5. Those are the terms. The like terms are 6x and x, and negative 2y and negative 5. No, wait, no, what am I doing? Those are not like terms. The coefficients, are 6, negative 2. The constants are just negative 5. I'm running out of colors here. Negative 5. Yeah, that's all I want you to do. All right, so when you're doing this in your homework, what you can do is just label them. And what I mean by that is you would just write something like terms, and then you would write 6x, x, negative 2y, negative 5. And then like terms, 6x, and then coefficients, and so on and so forth, right? Just like I've done here, or you can do it the way that I've done it too. I don't really care either way. But when you're doing it on a test, what's probably going to happen is that I'm going to give you like terms and then a blank, and then you'll have to write it out. Okay, so your turn. Identify the terms, the like terms, the coefficients, and the constants in the expression. So, welcome back. The terms would be 3n, 5m, negative 6m, and 2. The like terms would be 5m and negative 6m. The coefficients would be 3, 5, and negative 6. And the constant would be 2. Okay. Simplifying expression. So this is what we've been working towards, right? An algebraic expression is in simplest form when it has no like terms and it has no parentheses. So if there are like terms, you have to combine them. If there are parentheses, you have to distribute to get rid of the parentheses. Yeah, when you use the distributive property to combine like terms, you are simplifying the expression. Okay. So let's say we have these expressions. 4x plus 6 plus 2x. In order to simplify that, we would combine the like terms, right? So that would be 6x plus 6. Now this is simplified. Here we have 5n and negative n, which is 4n. And then we have 2 and negative 6. We combine those, that's negative 4. Here we have to do some distributing, right? So this is going to be negative 3x, 6y minus negative 3x plus 6y. Now here we have 6y and 6y as like terms. So that would be 12y. And then the negative 3x just stays where it is. Your turn. Simplify the expression. So here we have 4x and a negative 3x. So that leaves you with just 1x and then the 6. Here we have parentheses, which means we have to distribute that out. So 4 times q is 4q. 4 times 8 is 32 times p plus p. So now we have two like terms, and we're going to combine those. Okay, now let's say we have this situation that you have some money saved away in your savings account for a rainy day. And I have $25 more than you in my account. And we want an expression that combines both of our accounts. So first we have to do something called defining the variable, because there's something in here that we don't know, right? We don't know the value of your account. You have a savings account and we don't know how much that is, right? So that means we have to, the first step, anytime that we have an algebraic expression, is to define the variable, because you cannot just write, you know, I don't know, like that's not a number at all, right? 4 plus 3x, because this doesn't mean anything. I know we've been doing that, and it's not good practice to teach it like this, actually, because in my opinion, because if you learn about writing things this way, it seems normal, but it shouldn't be normal. You should never have an algebraic expression without a definition. Okay, so what we're going to do here is we're first going to define our variable, which means that we're going to write a variable. We can choose it to be anything. It can be S, right, for savings account. And what is S going to mean? It's going to be the amount of money in your savings account. Oh, my handwriting's getting bad. Okay. Once we have our expression, variable defined, then we can write our expression. So how much money do you have? Well, you have, oh, this thing died. Great. Why did this thing die? It's plugged in. Okay. S. That's how much money you have, right? And how much money do I have? Well, I have S plus 25. Now we're going to simplify this. There's two S's, so that's 2S plus 25. And this is an expression that represents how much money we both have. Your turn. Let's say that Joel and Josh both collect stickers, and that Joel has 16 more stickers than Josh. Write an expression in simplest form. So, welcome back. Let's say that C is the number of stickers, in Josh's collection. So once we have that, we can write the number of stickers in Josh's collection plus the number of stickers in Joel's collection. And Joel has the number that Josh has and 16, right? So that would be 2C plus 16. Good job. Now let's say that Ryan has as many stickers as Joel. He has so many stickers. And so we're going to write an expression to represent the total that all three people have, right? So in addition to the 2C plus 16, we're going to have another amount that that Joel has. And Joel has C plus 16, right? Joel has C plus 16. So we're going to add a C plus 16 to this expression. Now our like terms are 2C and C, which is 3C, and 16 and 16, which is 32. 3C plus 32. So many stickers, you guys. Okay. Oops. Here's your must do. 301, 302 odd. Enjoy.